Why use non-round dowels? Round dowels have long been the standard for load transfer and deflection control in concrete joints. Their dominance is mostly due to an early adoption and the resulting industry familiarity. But with the growing availability of cost-competitive alternates, it's worth revisiting the challenges we've observed with round dowels, and why many engineers are now turning to other options. Roughly 2 decades ago, both lab and field testing revealed how misaligned round dowels could restrain joint movement and compromise performance. Even in single-direction doweling, like what's used in roadway pavements, out-of-joint cracking has been documented. The cause? Joints locking up in several successive joints due to dowel misalignment. Now, when dowels are installed using pre-assembled baskets, any rotation of that basket can affect the alignment of every dowel at the joint. What was meant to ensure proper alignment can, ironically, introduce uniform misalignment. Today, agencies like AASHTO and some state DOTs impose maximum pull-out force limits for dowel bars, clear evidence of their concern for restraint due to misalignment. Thanks to funding from the Federal Highway Administration and implementation via the American Concrete Pavement Association, tools now exist to quantify dowel misalignment using magnetic imaging. By analyzing both the horizontal skew and vertical tilt, each joint can be assigned a score. That score can even affect payment, because owners and government agencies know misaligned dowels may lead to increased maintenance in the future. In short, dowel misalignment is a known issue and one of the drivers of innovation for alternatives. Elliptical dowels were developed, especially for roadway use, to reduce bearing stress and promote better load transfer. This innovation was backed by research and software from the ACPA, with support from companies like American Highway. Meanwhile, in the industrial sector, a different challenge emerged. The broad use of the laser screed allowed for placements of large concrete blocks, wide and long, at once. Here, the issue wasn't bearing stress, but restraint caused by dowel misalignment as the slab contracts or expands over time. In these cases, traditional round dowels became a liability as they do not allow for any lateral movement, which occurs between construction phases. Experts like Ward Malish, writing for the American Concrete Institute and the American Society of Concrete Contractors, pointed to cracking caused by round dowels restraining movement. His suggestion? Non-round dowels, especially square dowels housed in plastic sleeves that create a small void around the bar. These allow some misalignment without introducing restraint. The idea is simple: transfer loads without locking the joint. Field experience backed this up. Square dowels with void-forming sleeves help prevent cracking at joints and corners, particularly when delayed pavements created opposing shrinkage forces. Building on that, tapered plate dowels were introduced. These fit into plastic sleeves or pockets in construction joints and basket assemblies in saw-cut joints, where tolerance to movement is critical. Both ACI 330 and ACI 360 provide guidance here. ACI 330 states, using conventional round dowels in pavements with two-directional doweling or adjacent panels or lanes constructed at different times can create restraint, stresses and cracking. It then presents square dowels with compressible material or tapered plate dowels that create voids on their sides as alternatives. ACI 360 echoes the same ideas. It states, properly aligned smooth dowels that allow the joint to open freely, and plate dowels can minimize shrinkage restraint through geometry or compressible interfaces. Beyond alignment tolerance, plate dowels offer additional benefits. They're typically wider and thinner than round dowels. That means they reduce bearing stresses and increase concrete cover over and under the dowel, boosting resistance to shear cone failure, a more common issue in industrial slabs. Depending on the controlling failure mode, be it bearing, shear, or another, this geometry can also impact dowel spacing and overall system design. So how has the industry responded? In the roadway world, the choice was to stick with round dowels, but to rigorously monitor and control alignment, using tools like the magnetic imaging. In industrial applications, engineers took a different route, designing dowels and sleeves that prevent restraint, creating a more construction-friendly solution. The truth is, properly installed round dowels can work, and have worked for decades in millions of square feet of concrete, both in roadways and industrial slabs. But misalignment does increase the risk of cracking, and newer dowel technologies offer a more forgiving and often more reliable solution, especially in challenging placements. While tools like the dowel optimizer don't directly account for restraint stresses, designers should still carefully consider these factors, especially in applications with two-directional doweling or complex jointing patterns. Ultimately, the choice of dowel technology is a design decision, guided by performance objectives, project constraints, and experience.